Hey, all you cool cats and kittens. So today we're continuing Chapter 5, Section 4, but we've got a problem that is using our formula in a much different way. All right, so I've written the formula we're going to use for this example up at the top here. And notice I'm using u's and v's instead of x's and y's, but who cares? They're just variables. I'm using the u's and v's because when you do the problems out of the book, these are the variables they're going to be using. I tend to not use them because u's and v's often can look the same. So I'll try really hard to make sure my u's have little monkey tails on them and my v's don't. All right, so here's our formula. Sine u plus v equals the sine of u, cosine v plus cosine u sine v. All right, so today, here's what we're going to be given. Suppose we're given something a little different than we were before. Suppose we're given that the sine of u equals 4 over 5, and that 0 is less than u is less than pi over 2. And then we're also given that the cosine of v equals, let's see, well, where'd it go? There it is, negative 12 over 13. And that v is between pi over 2 and pi. All right, so really weird stuff. One thing I want you to note here is we are not given what u and v are. In other words, we're not told what the angles are. And that's what makes this problem very different than the ones that we did previously. And what's kind of cool about this is we don't ever need to know what our angles are, because notice the formula, all we need is the sine and the cosine of these angles, which we're given some of those. What is all this business here that they're giving us? This little domain, u is between u and pi over 2. That is simply telling us the quadrant that we will find angle u in. So here's our quadrants, just as a little reminder. So if u is between 0 and pi over 2, well, that means that u is in quadrant 1. V is between pi over 2 and pi. Well, pi over 2 is up here, pi is over here. So if V is between pi over 2 and pi, that means V is going to be in quadrant 2. And that's going to be necessary to know in just a minute. All right, so in order to use this formula, oh, by the way, we don't even have a question yet. They're going to ask us to find the sine of u plus v. So they're asking for the sine of u plus v. So in order to find that, we need the sine of u. Well, notice they give us that. We need the cosine of v, also given. But then we also need the cosine of u, which is not given, and the sine of v, not given. But we can use the information they do tell us to find these missing values. To do that, we're actually going to draw some right triangles. To me, that's the easiest way to find these missing values. Now, if you look at your example in the book, and this example is done in the book, they're going to use some trig identities. I think they use the Pythagorean identities to find the missing values. I have found through my many years of doing these examples that right triangles just seem to be easier for students to do. All right, so we're given the sine of u is 4/5. So I'm going to use that information to draw a right triangle. Sine of u equals 4 over 5. So I'm just going to draw just a generic right triangle. And since we're talking about angle u, I'm going to label this angle to be u. Okay, this little corner angle. And I could have put it up here. That does not matter at all. But now I have to label my triangle correctly. Well, sine, we know, by SOHCAHTOA, is the opposite over the hypotenuse. So here's angle u, so the opposite of that is 4. The hypotenuse is 5. So the cosine of u is going to be adjacent over hypotenuse. Well, what is our missing adjacent side? And if you don't remember your Pythagorean triples, then you can use the Pythagorean theorem to figure out this missing side, but you're going to find out that this missing side is 3. So the cosine of u is going to be 3 over 5. But now we need to pay attention to this given information about our quadrants. Angle u is in quadrant 1, so the cosine will be a positive answer. All of our trig functions are positive in quadrant 1. So cosine u is 3/5, and we're going to need that for our formula. So now we need to know the sine of v. Well, they gave us the cosine of v. I'll try not to cram it all in so close here. So the cosine of v is negative 12 over 13. And notice it's negative, but that's because we're in quadrant 2. V is in quadrant 2, and in quadrant 2, cosine is negative. Now, when we draw these right triangles, you always want to draw them without any negative values. Triangles, the sides of triangles are always positive values. You'll get back to the positiveness or negativeness of your answer by what quadrant that angle is in. All right, so now we're talking about angle V. So I have to draw a whole other triangle because this triangle was just about angle U. So this is going to be angle V. I just drew the same generic triangle, and I'm actually just going to label this angle V. So we're going to label it correctly. Cosine is adjacent over hypotenuse, so this is the 12. This is the 13. I'm ignoring the negative because I'm labeling a triangle. The missing side, if you need to, use the Pythagorean theorem, but this missing side you're going to find out is 5. So the sine of v, which is the last value that we were missing, is going to be the opposite over the hypotenuse. And then once you have that, check your quadrant. V is in quadrant 2, and in quadrant 2, sine is in fact positive. So my sine of v is just going to be positive 5 over 13. So now my formula for the sine of u plus v, I need 4 values. The sine of u, cosine v, cosine u, sine v. I now have all 4 of those values. 2 of them were given, and we just found the remaining 2. So now I'm going to fill all these 4 values into this formula. So the sine of u, they told me is 4/5. The cosine of v, we were given as negative 12 over 13. And this is plus because of our formula. And now the cosine of u, we found that by drawing this triangle. We found that to be 3 over 5. And the sine of v, we found to be 5 over 13. And now I have a little warning here. A lot of students are very tempted to do some cross-canceling at this point, and often you would be able to, but it's actually going to be easier for you if you don't do any canceling yet, because what's going to happen, we're going to try to add these 2 fractions, and if we don't cancel anything, then we'll already have a common denominator, so we won't have to mess with all that silliness. So now these 2 fractions, when we multiply those, we get negative 48 over 45. Right? Yep. Nope, 65. Helps if Miss Nelson can multiply. Much better. Plus, and then 3 times 5, that's going to be 15 over 65. So yes, I could have canceled some here, but now since I didn't, I already have a common denominator, and this ends up equaling negative 33 over 65. And that is our final answer. So we did this whole problem without ever even knowing what angle U and angle V were. So the problems we did, the 2 examples we did previously, although we're using the same formulas, they were very different type problems. So make sure you notice what's given. So this is for Wednesday's notes. Wednesday's April 1st. So here's the example that you have for that. And in fact, instead of doing the slideshow, I am just going to share these videos. So there will be one more example forthcoming. Thanks. Here's another example where we don't need the actual angles in order to do this summation formula. Let's see. Let's find the cosine of u minus v. My handwriting is not as pretty as it is when I'm writing on the big board, sorry. Let's find the cosine of u minus v, given that the sine of u equals negative 24 over 25. And the cosine of v is negative 4 over 5. And this time we'll say both u and v are in quadrant 3. So let's talk about that a minute. Quadrant 3, if you remember your ASTC, is where tangent is positive, so both sine and cosine are going to be negative. So sine is negative and the cosine is going to be negative. And notice that's true in the angles that we were given. The sine of u is a negative number and the cosine of v is a negative number. All right, so again, the formula for the cosine of u minus v. I like to write it out so that we can substitute our values in. That is the cosine of u times the cosine of v plus, with the cosine formulas, these signs are always opposite, the sine of u times the sine of v. So again, we're given two bits of information. We're given the sine of u, so we're given this, and we're given the cosine of v, which is here. So again, we still need the two missing bits of information, namely the cosine of u and the sine of v. So we're going to draw triangles for both u and v. So our first bit of information, we're given that the sine of u is negative 24 over 25. So I'm going to draw a triangle, a right triangle, and here's my right angle. And that's going to help me find cosine u. So I'm going to call, again, this angle here, that's going to be my angle u. All right, cosine is opposite over hypotenuse, and when you're labeling the sides of a triangle, you ignore the negative. So the opposite is 24, the hypotenuse is the 25. And notice it's never going to be drawn to scale, that doesn't really matter. So now we need to find our missing side, and you can use Pythagorean theorem. I strongly urge you to use a calculator if you do. Or I can abracadabra it and just tell you that our missing side here is 7. 7, 24, 25 is a Pythagorean triple. So now we have that the cosine of u from our triangle is 7 over 25, but we've got to remember that u and v are both in quadrant 3, so that means our cosine of u is negative 7 over 25. So the negative doesn't come from the triangle, it comes from the quadrant. That's the one reason we always need to know the quadrant. Now for v, for angle v, the given information is that the cosine of v equals negative 4 over 5. So I'm going to draw just a regular old right triangle. This time it's angle v. That's why we had to draw a whole new triangle, because we're not talking about angle u anymore. We have angle v. Cosine is adjacent over hypotenuse. So adjacent to v is 4. The hypotenuse is 5. So the missing side is going to be 3, using the Pythagorean theorem. So now the sine of v is the opposite over hypotenuse, so it's 3 over 5. But again, we have to check angle v is in quadrant 3, so the sine of v is going to be negative 3/5. So now here are our 4 values that we have to plug in to this given equation. So now we're going to say that the cosine of u minus v equals cosine u is here, negative 7 over 25. Cosine v is way over here, negative 4/5. That was our given information. Plus, and then we need the sine of u, negative 24 over 25, times the sine of v, which was negative 3/5. So now just use math to multiply these fractions. A negative times a negative, that's going to be a positive 28. 25 times 5, that's like 5 quarters, that's going to be 125. Negative times a negative is going to be a positive, so this is going to be plus. 24 times 3 is 72. Again, 25 times 5 is 125. Since they already have a common denominator, we can add those together. We get 100 over 125, which will simplify. 25 will go into both of those. So our final ultimate grand supreme answer is 4 over 5. And that's it. So now you can look under homework and do your homework problems for today. Thanks. Stay healthy.